Okay, so we're going to look now at the descriptive statistics. So in your SPSS output, we actually already asked for this. So by checking normality and outliers, we also already checked the mean and the standard deviations. So for age, we've got a mean of 24.34, but our median is actually 23. And because we decided to keep those outliers in this case you need to report the median because it's not affected by those higher scores, whereas you can see the mean is higher than the median because of those high scores in the data set. They've pulled the mean higher. So because we're keeping our outliers in, you need to report the median for age. So report the median and the standard deviation, which is 3.529. So because we're keeping in our outliers, that affects the mean. So report the median instead, because that's the middle number of your data set, which is 23, and it's not affected by the outliers. So because we're keeping our outliers for age, report the median and the standard deviation. So reporting age actually comes in the method in your participants section. So next week we'll go through more like section by section and what needs to go in each section of your lab report. But in your participants section, in the method, you'd just say how many participants there were. So 73. So that you'd say there were 73 participants, and then say their demographics, so a summary of their age and a summary of their gender, which we are going to look at now. Then in your results section, you'll report, first of all, your outliers and normality for the cola drinks, and then our descriptives section. So we've already got descriptive statistics. So if you scroll down to the descriptives for Coca-Cola and Asda Cola, we didn't have any outliers for these variables, so we can go ahead and report the mean. And the standard deviation. So for Coca-Cola, we've got a mean of 35.89 and a standard deviation of 25.92. And for liking Asda Cola, we've got a mean of 43.44 and standard deviation 27.76. What I'm going to ask you to do as well, because we're also going to be looking at whether there are any differences between males and females, I'm going to ask you to look at the mean scores for the drinks for males and females separately. And I'd recommend that when you write this up, you put it in a table. So you'll have a table of your descriptive statistics. So liking Coca-Cola and liking Asda Cola, and then your mean and standard deviation for males, females, and the total score, like the total group together. And because it's quite a lot of numbers, like to report that in the text, like to put all that in sentences is quite long-winded. So for your reader, it's easier to like make sense of it if they can just see all the numbers clearly in a table. I will give you a chance to put them in a table, and we'll check like putting it in APA format as well.
Sorry, you said that, or you want us to add in age and gender as well? Sorry.
So age and gender go in the participants section in the method, but in the table in results, you put the scores for Coca-Cola and Asda Cola for the total group and for males and females separately. You okay? You go to your output window. No, this just program is SPSS. Did you save it and closed it? Did you save it?
No.
Just quickly look.
This is the registered.
No, that's your data set. Sorry, close this. File. Open. Output. It might be this. Open it. No, it's not. It's right, this is all done. Then you can put file, save as, and I'm going to put it in your OneDrive so you can access it in there. And then for output for my report. Okay. So it's in your OneDrive so you can access it on any computer. Okay, where did we get to? So report in your so I want you now to look at males and females separately. Okay, so we've got our mean scores for the whole sample, and what we want to put in our table of results is also males and females separately. So we're going to go back to analyse descriptive statistics and. Let's just go to descriptives. Descriptive statistics, descriptives. And choose age, Coca-Cola and Asda Cola. Sorry, you can't do it that way. Sorry, you do have to do it through Explore. So go analyse descriptive statistics, Explore. Because we need to put in the factor list, we need the option to put gender. So in Explore, put age, liking Coca-Cola and liking Asda Cola in the dependent list, and put gender in the factor list. And what that will now give us is those dependent variables split by gender. Okay, so just click OK. Okay, it's got an error message, just a warning at the top that the about gender equals other, and I think that's because there's only one participant in the data set who reported not being male or female. So we won't summarise data for that one participant because that's just one person's data, and you should never sort of single out an individual participant in your data set. In your results, sorry. So we'll only report the Coca-Cola and the Asda Cola scores for males and females. We'll ignore that person who's not male or female. I don't expect you to report outliers and normality for all of these groups. So we'll just, you've already reported outliers and normality for your full your total sample. So now just go ahead and report descriptive statistics for your gender groups. So we've got descriptives for male, female, for liking Coca-Cola, liking Asda Cola, and age. Yours might be in a different order to mine if you put your variables in a different order to me. Okay, so what I recommend you do is put them into a table and put those into APA format, and then we won't do it right now, but when you've done it, like over the next couple of weeks, you can ask me to check it and check that you've got it in APA format. Yeah. APA has their website, which is APA Style, apastyle.apa.org, and this is their website, which gives all the guidelines for like their stylistics, so how to format a paper, so like it needs to be double spaced and like what the headings should look like and things, which we will talk about either next week or the following week. We'll talk about like actually sort of formatting and writing it up. But they also have in their style and grammar guidelines, they've got tables and figures. So if you go in there and click table setup, it gives you an example of what an APA table looks like, so how the borders should be, and like what your column headers should look like. If we've got time, we can come back to this at the end of today's class. But otherwise, once you've done it yourself, let me check it in class so that I can see if you've, and I can give you some pointers. Okay, so that's it for descriptive statistics. So age goes in the participants section. We also need to report the number of males and females in the participants section, and then in your results section, first of all you do your outliers and normality for Coca-Cola and Asda Cola, and then your descriptive statistics for Coca-Cola and Asda Cola. As I said, put them in a table in APA format. So for the your mean and standard deviation scores for the total sample and males and females separately in one table. And then all you actually need to write is just something like see table 1 for the Coca-Cola and Asda Cola liking scores, so something like that to direct your reader to the table. And then we're going to move on to the exploratory analysis. So we now want to look at like whether there are any correlations or differences between our groups. So on the slides, we're up to here, slide 8. So we're going to look at the impact of demographics, of gender and age. And then lastly, we'll look at the inferential analysis to test our hypothesis, which will be seeing whether there's a difference between those mean scores for Coca-Cola versus Asda Cola. Because we already can see from the descriptives that Asda Cola was rated higher, but we're going to test with a t-test whether that difference is significant. Okay, so I'm just going to give you the theory about t-tests. So a t-test is a statistical test that's used for comparing two means. And the null hypothesis would always be that there's no difference between the two mean scores. And your hypothesis that you're testing would be that there is a difference between the mean scores. So, for example, Sama's tea study example, looking at the level of antioxidants between green tea and matcha tea, we could compare those with a t-test because we're comparing two mean scores. In this case, we've got scores for we've got a mean score for Coca-Cola and a mean score for Asda Cola, so we can use a t-test to compare those mean scores. We've also got a group of males and a group of females, so we can use a t-test to compare the male's score for Coca-Cola compared to the female score for Coca-Cola. And the same for Asda Cola. We can compare males and females for their score for Asda Cola. Okay, so a t-test is always comparing two mean scores. And your hypothesis would always be that there's a difference between those means. So your null hypothesis says that there's no difference between the means. Everyone okay with that? As with the other parametric tests that we've talked about, a t-test does have some assumptions. So these are the assumptions that assumptions about the parameters of your data that need to be met. We've already checked for outliers of normality, which are important assumptions. You need to make sure that the behaviour of your participants is not affecting one another. And the one other thing we need to check is the homogeneity of variance. So when we come to compare the gender groups, because it's different groups of people, we need to test whether the variance of their data is similar to the variance of the other group. So we need so even if one group, like males or females, has higher scores than the other, that's fine, but we need to check whether the variance, so like the shape of the histogram of their data, is similar between the two groups. So SPSS will prompt us to do that. Are you going to ask something?
Yeah, sorry, could you repeat that again, if you don't mind?
About homogeneity of variance.
Yeah.
Homo just means the same. So homogeneity of variance means that the groups have got the same variance. Okay, homogeneity is like homo is the same, so there's the same variance. So this test of homogeneity of variance is the assumption that both of our groups have got like similar shaped histograms, basically. And SPSS will prompt us and will give us the results. So if you're comparing different groups of people, you need to check that they have homogeneity of variance. As I mentioned earlier, central limit theorem says that because we've got more than 30 participants in our sample, even if we violate these assumptions, we're probably not going to violate them very badly. So because we've got more than 30 people in our sample, we can go ahead and use a t-test anyway. Because if we violate the assumptions, then that's normal for that sample, basically. So we're going to go ahead and use the t-test, but you still need to report that you've checked the assumptions and whether you met them or not, and then and if we violate these assumptions, then you just need to say, well, central limit theorem says that because we've got more than 30 in our sample, we can go ahead and use the t-test anyway. So that's it. We've already checked for normal distribution and outliers. We will be prompted to test for homogeneity of variance. We know that our dependent variable is a scale variable. So we've got the total scores for the Coca-Cola and Asda Cola was scored from 0 to 100, so it's a scale variable. And we know that our participants' scores are not dependent on one another. So the only place that we have violated an assumption was we had kurtosis on our Asda Cola variable. So you just need to say that was the case. And then justify that we're going to use a t-test anyway because our sample size is bigger than 30.
that wasn't the only violation, there were so many other,
I think it was just that, and age.
but I feel like every time we did a result, it was, you know,
Significant.
yeah,
The, the age was significantly skewed and leptokurtic. And
the age doesn't matter.
we are going to do a correlation with age, but we're going to use the non-parametric
Okay.
one because of the outliers. And yes, the Asda Cola and Coca-Cola Shapiro-Wilkes test was significant. And then when we looked further, the most significant issue was with kurtosis in the Asda Cola. So you just need to say that we violated the assumption of normality, but our sample is big enough to go ahead and use t-test anyway.
Got you.
So there are 3 types of t-test. Firstly, there's a one sample t-test, which is where you collect a mean from your group of participants and you compare it to like a number that you already know. So you might use this, for example, if you tested IQ around the university. We know that the mean, like the population mean for IQ is 100. So you might test students around the university and then compare their mean to 100 to see if your students are have a significantly different IQ to the known mean. Make sense? So if you already have a score that you're comparing to, or like if you collected some new data and you were comparing it to like some previous literature, you could collect your new data and then compare it to what somebody else previously reported in their work. So that's your one sample. We're not going to use a one sample t-test for this research, but we are going to use these other 2 types. So the independent samples t-test compares 2 independent groups. Okay, so this would be like when we compare the males and females, they're different groups of people. So you use the independent samples t-test. People often also use this if you were comparing a treatment group with a control group, or an intervention group with a control group. Because they're different groups of people, you'd use an independent samples t-test to compare them because they're independent groups. Does that make sense? Okay, so and then you've got your dependent samples t-test, which is also called a repeated measures t-test or a paired samples t-test. SPSS calls it a paired samples t-test. And this is when the reason they're paired samples is because the same participants took part in 2 conditions. So you've got 2 different means, but for the same participant. So in our experiment that we did, each of you took part in the Coca-Cola test and the Asda test. So each of you has got a score for Coca-Cola and a score for Coca-Cola and a score for Asda Cola. So that's paired samples or repeated measures because you both took part in both. You all took part in both conditions. Okay. This dependent samples or paired samples t-test is also often used, like if you're testing an intervention or medication. If you tested people before the intervention and then after the intervention, you'd compare their score before compared to after with a paired samples t-test. Does that make sense? Okay, so that difference just depends on whether the scores, so you're always comparing 2 means. So the independent samples test is if those means are from different people, and the dependent samples is if those 2 means are from the same people.
Okay.
Yeah?
Yeah.
So independent if the people are independent, if the groups are independent from one another, and dependent if the scores are dependent on the same person, the same group of people. So if you've got 2 scores from the same person. So our test was a repeated measures test because you did one condition and then the next one. Everyone okay? All right, so those are the different tests. So the stages of the analysis. So first of all, you explore your data, which we've done. We've checked for outliers, normality, and we'll check for homogeneity when we do that t-test. We've looked at our box plots, histograms, and our descriptive statistics. So now we're here running the t-test. It prompts you to use non-parametric tests if there are problems with the data. As I said, because our sample is more than 30, we're going to go ahead with the parametric t-test. There is a non-parametric equivalent called the Mann-Whitney U-test, but we're not going to cover that in this module. So you don't need it for your lab report, and you won't need it for your exam. But it's just good to know that for every parametric test, there is a non-parametric equivalent. And then lastly, once we've done our t-test, if it's significant, we'll need to calculate our effect size. The next slide is a summary slide, but we're going to jump back to SPSS now and your data set. I just realised we didn't actually check how many participants were in each gender category, and so we'll just do that quickly before we do the t-test, which is in analyse, descriptive statistics and frequencies. So you just want to check gender. And just click OK.
We don't do anything with the statistics or anything like that format?
No, just it will just give you this little table that tells you the frequency and percent of males and females. So when you report this in your participants section, you just say there were a total of 73 participants took part in the study. There were 11 males, and then in brackets 15%, and there were 61 females, 83%, and one participant who wasn't. We can say that they were non-binary, and then in brackets 1.4% or 1% if you just round it. Okay, so it's just a very concise description of the demographics of your sample. Okay, so that's gender. Okay. So that was analyse, descriptive statistics, frequencies, and then just put gender as a variable. Okay, now let's start with the correlation, because we did correlations last week. So we're going to first explore whether there are any associations between the demographics and the liking Coca-Cola or liking Asda Cola. So to look at whether age is associated with liking Coca-Cola or liking Asda Cola, we can use a correlation because we've got two scale variables. Age is a scale variable and the liking scores are scale variables. So we can look at whether they're correlated. Do you remember how to do correlation?
Analyze correlations and bivariate correlations.
Yeah, simple. So analyze, correlate, and bivariate. Analyze, correlate, and bivariate. We want to see whether age is associated with either of the liking scores. So you can move all of those into the...
Why would I only have 3? 3 categories, source variables. Is that wrong?
Yeah, you went into a different option and correlate. And then bivariate, yeah, the second one. Yeah, you went into the top one.
Got it.
Okay, so move your 3 variables, age, liking Coca-Cola and liking Asda Cola, into the variables box. And then remember, because we've got those outliers for age, we need to tick Spearman instead of Pearson. Make sure you tick Spearman, because Pearson's will be affected by the outliers.
Sorry, I missed the T value, so it's gender,
That's it.
and then,
That's it.
but then when I do it, it doesn't go.
No, so it's just a number of
How do I get your?
analyse, correlate, bivariate.
No, the graph, I don't have that graph.
That is, you should have that above. Where's the rest of the output? Maybe you saved it and closed it.
Yeah.
Hopefully you saved it. Carry on from the output that you've got there, and then try and find what we already did at the other part of the class.
And it's here, and you know how to find it, really.
Maybe you saved it as a file. This one is output 4, so you've obviously had 1, 2, 3 open.
And it's like here, usually, when we find it.
Wherever your computer saves its files,
Okay,
you need to search for them.
okay, no worries.
Right, but carry on from here.
Yeah, so this is correlate, right?
Analyze, correlate, and then bivariate. So once you've done that, so click. Remember to click Spearman.
Bivariate? Bivariate.
Are we not going to do it one day because that's our hypothesis?
Yeah, that's what I'm getting to. So
Age, liking.
we're looking at whether there's a correlation between age and liking cola drinks. We need to decide whether we think this is a one-tailed or a two-tailed hypothesis. So basically we're testing the hypothesis that there'll be a correlation between age and liking cola. So what do you think? Do you think there's any reason to think that there will be a correlation with age?
No.
Personally, I don't either. I don't think that like being older or younger relates to higher preferences or lower preferences.
Can I ask, so when I moved each to the other side and the liking of cola or as the cola to the other, mine went away from the first box.
Yeah, I don't know why mine.
Oh, okay, so it's
I don't
not-
know why mine haven't moved.
That's okay, I just wanted to make sure I'm not wrong or there's nothing wrong with mine.
They've gone
There
out.
we go.
So I think we can keep it as two-tailed because we don't have a specific hypothesis about whether it's going to go one way or the other. So keep it as two-tailed, and then you can just click OK. Okay, so I'll give you a moment now to have a look at this correlations table yourselves, and you can talk to one another and see if you can figure out what it means, whether you've got anything significant there or not. Why is everything nice? Is it?
It's this
The last one.
You've done Pearson's, so
Yeah, that's what I wanted to ask.
Mm. Yeah, so
Yes.
tick Spearman,
Okay.
yeah, and untick Pearson.
Oh, okay.
choose here.
Tick Spearman,
Because
untick
we have
Pearson.
outliners.
It's because of our outliers. We need to do the non-parametric one. So I just want to click OK. And then what I would do is delete that one so that it doesn't confuse you. And if you did it as well, Sam, I'd delete yours because your Pearson one.
I didn't do it.
Okay, cool.
Thank you.
Right. You okay?
Yes.
You okay?
Yeah.
You okay?
Yeah, I'm okay.
So
Okay.
Pearson,
Right.
um,
Tick Spearman.
and so
Yeah,
that's why
yeah,
Untick this.
well,
Untick Pearson.
that's why we chose to keep Spearman.
yeah,
Okay.
then it should only be-
Right. Scroll to the
If you
bottom.
don't have outline. Pearson. Reason being?
All the way down.
Because of
So these are your correlation results that you just tested, so the correlation between age, liking,
Yeah,
so see if you can make sense of what this means and talk to an associate.
So we did
See if you can make sense of it together.
we see it's skewed towards the positive side, and because there are two outliers, because there are two outliers and even if you say experiment any form of correlation to
Okay, so what we got going on? Yeah, go on, Yash.
So we have age in correlation with like cola, which is 0.688.
Age with liking Coca-Cola.
P
So
value is
the
0.688,
p-value is 0.688,
which is
yeah.
around 68%. So that's not really significant.
Correct, yeah.
And then we have p value for Astra, which is 15%. Again, that's higher than 5%. So
Yeah, exactly. So our p-value for the correlation between age and liking Asda Cola is 0.15. So also because it's not below 0.05, it's not significant. So we've got no significant correlation between age and liking Coca-Cola or between age and liking Asda Cola. Okay? Which, I mean, we didn't have a hypothesis really that there would be an association between age and liking the drinks, so it's not really surprising. We have got a significant correlation between liking Coca-Cola and liking Asda Cola. Also, like where you don't need to report this one, it's not very interesting, but of course there's like, it was the same people testing the drinks, so if they liked one, they were likely to also like the other. So it's not really surprising that there's a correlation between how people rated the Coca-Cola versus how they rated the Asda Cola. Yeah?
In the notes in the past, we were using Pearson, and now we're using Spearman.
It's because of our outliers. Pearson's is the parametric correlation, and Spearman is the non-parametric equivalent. So because we decided to keep our outliers for age, we're using Spearman, because Pearson would be affected by the outliers.
Okay.
Okay, so when you write this up, so this is the next section in your results section. So if you want to like make notes on this now, you can use this for your results section. You need to say what test you've used and which variables. So something along the lines of Spearman's row was used to investigate the correlation between age and liking the beverages. And then you just say that there was no significant correlation between age and Asda Cola, and then your statistics in brackets, which I'll come to exactly how to put your statistics in APA format. And there was no correlation between age and liking Asda Cola, again with your statistics in brackets.
Last one is there was no correlation between age and Coca-Cola.
Yeah, so there was no correlation between between age and liking Coca-Cola or Asda Cola, to be more concise. And you just need to report your statistics as well, which I'm going to come to how to put your statistics in APA format.
So is the effect size of Spearman similar to Pearson though, in the fact of 0.10 small effect, 0.3 medium effect?
Yeah,
and
yeah. Yeah, so the R value. So in this case, because they're not significant, you don't need to interpret the effect size because there is no effect to interpret. So you still get a value, but you don't need to interpret what it means because the effect is not significant. So you just say there was no significant correlation between the variables. Okay, so that's it for age. That's your age investigation. Now we need to look at a t-test for gender. So we'll see whether there's a difference between the males and females for their score for Coca-Cola, and whether there's a difference between males and females for their score for Asda Cola. Okay, so again, go analyse, and this time compare means, because we're comparing their mean scores. So if we're comparing genders, would this be an independent samples t-test or a paired samples t-test? Yeah, it's independent, yeah, because we're comparing, like, males and females are independent from one another. They're independent groups. So analyse, compare means, independent samples. Then you want to go to in test variables, move your liking Coca-Cola and liking Asda Cola are the variables we're testing. And then move gender, because we're comparing groups, we're comparing gender groups, so put gender as the grouping variable. So Habiba, we're doing the t-test to compare the gender groups. So go analyse, compare means, and independent samples t-test.
This is the t-test, so this is the hypothesis.
No, this one we're just looking at demographics still. So this is the independent samples t-test. To look
Which
at
are the
gender.
variables?
So, and then you're here where I am. So put your liking Coca-Cola and Asda Cola as the test variables, and gender as the grouping variable, and then you need to click define groups. You can leave it as 1 and 2, because in this data set, males are coded as 1 and females are coded as 2. If you had a bigger data set where you wanted to compare groups that were coded as different numbers, this is where you change the numbers to, like if I had males coded as 5, let's say, then I would put 5 here. But we can leave it as 1 and 2 because our males and females are coded as 1 and 2 in this data set. So you just need to click continue to confirm. Everyone okay?
It's not
Yeah.
Is it not working? If you've done that, you just click OK, and have a quick look at your tables that you get in your output.
So
Yeah, that's it. Just click
if my
continue.
group is not,
Yeah, that's it. Now it's got gender 1 and 2. Now click OK.
for me it's not showing 1 and
Just put them in.
2, and then I click. So previously I was trying to click continue, it was not taking.
Are you the version of SPSS?
Probably.
Yeah, it's not.
Yeah. Okay. It's taken now.
Yeah, that's fine. I'll just click OK. That's it. You okay? Yeah. Perfect. Click define groups. Okay, and continue. That's fine.
What I don't really understand, because I feel like we did the t-test, and then we did the correlation, and now we're going back to the t-test.
No, I explained what the t-test was, but we haven't done it yet.
Okay, got you.
Okay, so you've got your t-test results. So first of all, it just gives you some statistics on the scores for liking cola and liking Coca-Cola and liking Asda Cola. So you've got your mean and standard deviations there. And then in the independent samples t-test box, we've got our actual t-test results. One of the assumptions, remember, is homogeneity of variance. So because we're looking at two different groups of people, males compared to females, we need to check that the variance of their scores is similar. And Levine's test does this. It's here in the table. Levine's test for equality of variances. So it's testing whether the variances are equal. Ideally, we want Levine's test to not be significant, because if it was significant, it would say that there is a difference between the variances, which for our assumptions would be a bad thing. So we check Levine's test, and here where it says sig, that's our p-value, is 0.735. So is it significant?
No.
No, which is good. We didn't want it to be significant. So this Levine's test shows that our variances are equal. Okay, it's testing equality of variances. So it shows that our variances are equal, which means that it means that we can read the statistics along this top line of the table where it says equal variance is assumed. If you're in the situation where Levine's test is significant, you just read the statistics from this bottom line, equal variance is not assumed. Okay, so it doesn't affect the way that you do your results, you just read a different line of the table. But ours is not significant, so we can assume that our variances are approximately equal. So we read the data from this top line of the table. So when you report it, you've got your T statistic here. Your DF is degrees of freedom. And then you've got your significance test. If you've got the latest version of SPSS, you should have a one-sided and two-sided P. Have you got that? Or have you just got two-sided?
Yeah, just have to.
You've just got two-sided. So if you've got an older version of SPSS, you'll only have a two-sided P. But in this case, that's fine, because I don't think we have a hypothesis that males or females would be higher than the other, do we? No. So we're testing the hypothesis that there'll be a difference, but we don't. It's only a two-tailed hypothesis. We don't have a reason to say that males or females would be higher than the other. So we're going to keep it two-tailed. So you report your two-sided p-value. Okay. You'll notice that the one-sided p-value is just half of the two-sided one. So report your two-sided p-value in APA format, and we'll come to how to report it in APA format. So when you write this up, you just write something like that an independent samples t-test showed no significant difference between males and females on their scores for Coca-Cola.
Can you say that again?
Yeah, independent samples t-test showed no significant difference between males and females for their scores for liking Coca-Cola.
Sure, it's not significant.
No significant difference, because the p-value is above 0.4. Okay, so having done that one together, you have a look now at the same for liking Asda Cola. So check Levine's test to see whether you have homogeneity of variance, and then check your t-test, which is your p-values are reported here in the table. So check for liking Asda Cola and see if you can interpret what it means.
So the T is the t-test, right?
Yeah.
And
Mhm.
so here the sig value for S4 is 0.808, which is higher than 0.505.
Mm-hmm.
So there is no significance.
Yeah, that's Levine's test.
Right, but I did not understand the P value one.
These ones you just need to report, so when we come to reporting it, you need these figures from the table.
But what does it signify?
So the T, it's a ratio of the difference between the two groups, so a ratio of the difference between males and females. So essentially the bigger the T value, the more likely it is to be significant.
Okay. So if I'm just comparing these two, that means 0.790.
Mm-hmm.
Yeah, so you just report that. So you check your Lean's test and then you check your C here as well.
All right, so what does it mean?
Tell us.
You tell me.
I have to be honest, I'm kind of lost. I don't know if I'm the only one who's feeling that way, but
Okay, so we're using a t-test to check whether there's a difference between males and females for their scores for liking Coca-Cola or liking Asda Cola. So we've got the scores. Let's start with Coca-Cola. So we've got the scores for males, how much they liked Coca-Cola, and we've got our scores for females, how much they liked Coca-Cola. We know that the mean so males rated Coca-Cola an average of 30 and females rated Coca-Cola with an average of 37. And what we're doing is seeing whether that difference between 30 for males and 37 for females, whether that difference is significant.
okay.
So that's what the t-test does. It compares that 30 to the 37 and to see whether that difference is significant.
Okay.
And the same for Asda Cola. So on average, males rated Asda Cola 37 and females rated Asda Cola as 44. So again, we're using the t-test to compare whether 37 is significantly different from 44. Make sense?
Yeah.
Okay. So, but one of the assumptions for doing the t-test is that the variance for males is significantly is similar to the variance for females. So if we were to plot their liking scores on the histogram, the shape of the histogram should be similar for males compared to females.
Can you repeat that?
Yeah.
137 compared to 44?
The t-test is comparing, so the mean for males rating Asda Cola was 37, females rated it 44. So the t-test compares whether that rating for females is significantly higher than males. It compares those two mean scores to see if they're significantly
And here it's
different.
0.7, so 0.77, right?
Where do you get that from?
Under the T.
The T doesn't tell you about significance, the P does. Your P value is
So it's SIG.
SIG.
So
Yeah,
it's
so
0.8.
SPSS calls it SIG. So you've got, but first of all, we need to check Levine's test for equality of variances. So the variance is like the spread of the data. So if you plotted males on a histogram and plotted females on a histogram, the variance is whether the shape of those histograms is similar. Okay, so to do a t-test, you ideally you want the shape of their histograms to be similar to one another, and that's homogeneity of variance. So homo meaning the same, so homogeneity of variance. So similar variance in the scores.
So I have a question then. Is there any way that we can see the histogram, like the shape of it?
Yes, we already asked for it. We've got,
Okay.
so here, if you scroll up in your data, that's liking Asda Cola for males. and that's liking Asda Cola for females.
Yeah.
And then above that, I should have the Coca-Cola ones as well. But if we look at Levine's test here, the SIG column is your whether Levine's test is significant, and it's not significant because it's above 0.05, which, although they look a little different, Levine's test has determined that they are close enough to one another, so we've met the assumption of homogeneity of variance. Our variances are similar enough.
And what's the 0.5 coming from?
Levine's test is the p-value for Levine's test is above 0.05.
So it's significant.
It's not significant. Which means that there's no significant difference between the variances of our two groups, our males compared to females. The variance is similar, which is a good thing. And it means because it's similar, you can read your results from this top line, equal variance is assumed. So that was Levine's test, just tests whether the variances are similar. And then next to it in the same table, you've got your t-test results. So you've got your t, your degrees of freedom, and then importantly your p-values. So we're looking at the two-sided p. So for Coca-Cola again, our two-sided p-value is 0.432, which is not significant because it's above 0.05.
Whenever it says SIG, that means P and P means 0.05. So you automatically compare it with.
Yeah. Yeah, so when we're looking at p-values, 0.05 is our 5% cutoff.
Is that like the 0.05 that's related to the Z-score, or like it's completely unrelated?
Z-score, the cutoff is 1.96, which would be the equivalent of having a p-value of less than 0.05. So this is your P is for probability. So this, if you multiply this by 100 to give you a percentage, this means that there's a 43% chance that your null hypothesis is true. So there's a 43% chance that there's no difference between males and females. Yeah? If you look at the liking of Asda Cola, again, look at your Levine's test, and it's not significant, which is good. So you can read along the top row that equal variance is assumed. And you've got your two-sided p-value is 0.442. The p-value is 0.442. Again, not significant. And so the way that you'd write this up was that there was no significant difference between males and females for their scores for liking Coca-Cola or Asda Cola.
Sorry, I'm going to sound really stupid. So if the SIG value is higher than 0.5.
0.05.
Okay, higher than 0.05 in the SIG, which is the p-value in the Levine test.
Mm-hmm.
Then it means it is
not significant.
not significant.
Yeah.
Okay, thank you.
For significance, you're looking for tiny numbers, because that tiny number means there's only a tiny chance that your null hypothesis is true.
So what you said, the way to write that is there was no significant speed between males and females liking us or
Yeah, basically. Yeah, for their liking scores. Okay, you'll have this video to come back to, remember? So I just want to do this final test, which is our hypothesis test, and then and I'll ask Martin to upload this, which she'll probably do either today or tomorrow. Okay, so stick with me for the final test. It's another t-test. So again, we go to analyse, compare means, and this time it's the paired samples t-test because we did the repeated measures. you all did the Coca-Cola and you all did the Asda-Cola conditions, so it's paired samples. This time you just need to move your two variables, liking Coca-Cola and liking Asda-Cola are the two means that we're comparing. So move those across to the box, and that's it. You just click OK. You'll notice when you look at your output this time, no Levine's test, because we're comparing the same group of people for their score on one condition and the same group of people for their score in the other condition. So because it's the same people, you don't need to test the variance between their scores. It's just assumed to be similar because you're testing the same people. So you don't need to report Levine's test for this one. So again, at the top it gives you a summary. So you've got your liking Coca-Cola, the mean score is 35, and Asda-Cola, the mean score is 43. So we can see, on average, the participants rated Asda-Cola higher than Coca-Cola. We'd already seen that in our descriptive statistics. So this t-test is comparing whether that mean score for Asda-Cola is significantly higher than the mean score for Coca-Cola. So look here in your paired samples test box and look along to, you've got your t-statistic and your degrees of freedom again, and then you've got a one-sided p and a two-sided p. Which one should we be looking at this time?
One-sided.
One-sided, yeah, because we had a directional hypothesis. We predicted that Coca-Cola would be rated higher than Asda-Cola, so it's a one-tailed hypothesis. So we look at the one-sided p, which is 0.002. Is it significant?
Yes.
Very, yes. So this means there's only if we multiply it by 100, it means there's a 0.2% chance that the null hypothesis is correct. So only 0.2% chance that there's no difference between Coca-Cola and Asda-Cola scores. In other words, there's a 99.8% chance that there is a difference between the Coca-Cola and the Asda-Cola.
I just have the two-sided one. The one-sided doesn't
You
come up.
must have a slightly older version of SPSS. So the one-sided is just the two-sided divided by 2.
Okay.
So when you write it up, just divide by 2 to get your one-sided. If you've only got two-sided, divide by 2 to get your one-sided p. So when you write this up, you'd say something like, contrary to the hypothesis, Asda-Cola was rated significantly higher than Coca-Cola. And then just your statistics in brackets. Oh, sorry, you need to say the name of the test as well. So you'd say that a paired sample t-test showed that Asda-Cola was rated significantly higher than Coca-Cola. Okay, so when we looked at the descriptive statistics earlier in the class, we'd already seen that the Asda-Cola was rated higher, but the t-test now tells us whether that difference was significant or not, and so it is significant. We know that from the t-test. Okay, everyone okay with that? Okay, so when you come to writing this up, we've gone through this class in order of how to write your results section. So you start off with your outliers and normality, then your descriptive statistics, which you can put in a table, then your exploratory analysis looking at the demographics, so the age correlations and the gender t-test, and finally this one, your hypothesis test. Okay, so that's it. Okay, try and when you write it up, try and be quite concise with your writing, and make sure that it's very clear which test you did and what the results mean. You, as I said, you don't need to over-explain things, so you don't need to say like the p value was significant because it was less than 0.05. You can assume that your reader knows that what p values mean, so you just need to say whether it was significant, like what the p value was and whether it was significant or not. So try and be quite concise and don't over-explain, but it needs to be clear to your reader that you understand what you've done and what it means. So when you get to this hypothesis test at the end, you can link it back to your hypothesis. So say, contrary to the hypothesis, we found that X, Y, Z. Okay? Everyone okay?
I mean, this is going to sound silly, but
Sorry.
no, but surely we could have done the last one and just that.
You need to go through the stages though, because if you just did the last test and you didn't report any descriptive statistics, your reader isn't then able to sort of follow the story. Like I always think of a lab report as telling a story, so you need to sort of feed your reader the information in an order that makes sense.
Okay.
So you have to check the assumptions, like outliers and normality, and the homogeneity of variance for one of the tests. You have to check those assumptions, and then reporting your descriptive statistics in a table helps your reader to then interpret your t-tests. So then when you come and do the t-tests, you've already given them the information in the descriptive statistics. So, Yash.
2 questions. The significance, sig value or the p value, we noticed that it's smaller than 0.5. But how did we reach to the conclusion that alpha is more like 5?
Yeah, so it's in the descriptive statistics. So it's here. You've got the mean score for Coca-Cola was 35, but the mean score for liking Asda Cola was 43. So Asda Cola is higher. We also looked at it earlier, like when we did the Explore, when we looked at each of our variables, we also already looked at the descriptive statistics there.
Second question is, we checked the in the previous table we checked t value. I'm still not understanding what does t value signify and how do we compare? So it shows minus 0.79. So what does that mean?
You don't need to worry about interpreting that for now. Just worry about the p value, so whether it's significant or not. Like if you do more t-tests, that you'll see the bigger the t value, the more likely it is to be significant. Like the more difference there is between your groups. So it's a ratio of the means from one group to the other. But don't worry about interpreting it, because you don't need to for your lab report. You just need to report it.
Okay, so I just need to say that t value for Coca-Cola was minus 0.7.
Actually, there is a way to report it in APA format. So in the next section of the slides, one last thing. If you've got the newer version of SPSS, you should have this box at the bottom. If you've got an older version, the instructions for how to do this test are on the slides, but you should have this box at the bottom with Cohen's D, and this point estimate is the effect size. So this is like how strong the effect is. So because we've got a significant difference between Coca-Cola and Asda Cola, we can look at Cohen's D, which is minus 0.348, and I've put on the slides how to interpret this. So a small effect would be like less than 0.2, and medium would be around 0.5. Ours is like somewhere in between, so we could describe it as like a small to medium effect. So just add that in your sentence when you write this up. Okay, and then this is APA format. So on the same slides, when you write your sentence. So for example, so this is the paired samples one. So you'd say, for example, the paired samples t-test showed a significant difference between the scores for liking Coca-Cola versus Asda Cola. And then in brackets at the end of the sentence, you put your results in this format. I've mentioned before, APA is really picky about exactly how you report, like how you format things. So in brackets, your T and your P need to be in italics. And notice where the spaces are. So there's a space each side of a mathematical sign like equals or less than. The p-values are always reported to 3 decimal places, so rounded to 3 decimal places, but any other statistics like your t-value are reported to 2 decimal places. Okay, so you can copy and paste this from the slides and then just replace the numbers with the numbers from your own results table. Just make sure that your formatting for this is quite precise, because it's part of the marking criteria is whether your results are in APA format. So you've got your T statistic, you've got your degrees of freedom, and you've got your sig, your p-value. And then very similar for the independent samples t-test, like the format is exactly the same, T and then your degrees of freedom, your T statistic into 2 decimal places and your p-value to 3 decimal places. Okay, so be very precise with like the italics and the spacing when you're reporting in APA style. Okay, so next week we're going to look at actually writing all this up. So we've just done the results section today. So if you tidy this up, and then once you've had chance to make your table and put your results in APA format, I can look at that in class for you. So if you've got that ready for next week, I can look at it next week or the week after. Bear in mind that it's Easter break for 2 weeks before your test, and your lab report is due the day that you get back from Easter break. So, and
the 6th of April.
Yeah, and that's week 9, isn't it? Yeah.
But are we going to have a test in class also? No.
No. Your second assessment is the SPSS assessment, which is like the week after the end of term.
And the lab report that we have to do?
That's due week 9.
And are we going to start working on it in class? Or
We're going to talk through it next week. Yeah, so you won't really be working on it in class, but all of the notes that you take from next week, you can form those into parts of your lab report.
And it needs to be based on all of this?
It's this, yeah. Yeah, so today we've done the results section. So I'd recommend, like, while it's fresh in your mind, try and like do this results section as soon as you can. So, like, we've gone through it today, so while it's fresh in your mind before you forget anything.
Is there an example that we can?
Yeah. In the on Blackboard, in the lab report folder for so module assessment and submission, then lab report, and then there's some example lab reports. So there's like an overview of the format, and then some examples. This paper by me about sleep and learning, I'm pretty sure that one is in APA 7 format. The other two might be in APA 6, so there might be some minor differences. So yeah, so you've got some examples there.
And so, do you feel like every experiment would follow this type of dum 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 we've seen?
Pretty much, yeah. Like, some are more complex than others, but like essentially most like lab reports should follow this formula. So like checking for assumptions, removing any outliers if you're going to, then your descriptive statistics, and then any tests that you've done. That is quantitative analysis is quite formulaic, so, and then you just need to guide your reader through like exactly what you've done. Right, I'll stop this recording.